Hello, welcome friends. Me Anila. The topic of my discussion is about numericals on buffer part 3. But before this, don't forget to like and subscribe my channel and press bell icon. Friends, in this video, I will tell you how to solve toughest numericals on buffer part 3. Before coming to buffer, I want to give you a brief introduction about acid and bases. Acid is a substance that donates hydrogen ion in aqueous solution. Base is a substance that accepts hydrogen ion in aqueous solution. Strong acid dissociate completely in aqueous solution such as sulfuric acid. Weak acid dissociate partially in aqueous solution such as acetic acid. Strong base dissociate completely in aqueous solution such as sodium hydroxide. Weak base dissociate partially in aqueous solution like ammonia. Now what is conjugate acid and conjugate base? For example, if we have a weak base ammonia, in aqueous solution it dissociates into ammonium ion and hydroxyl ion. Ammonium ion is the conjugate acid of ammonia. Similarly, acetic acid in aqueous solution dissociate into acetate and hydrogen ion. Acetate is the conjugate base of weak acid. Now, what is pH? If pH ranges from 0 to 14, if pH is equal to 7, it is neutral such as water. If pH is less than 7, it is acidic. If pH is greater than 7, it is basic. Similarly, pOH is reciprocal of pH. Now, what is buffer? Buffer is a solution which resists large changes in pH. For example, we have a buffer system of acetic acid and sodium acetate. In this buffer solution, if we add strong acid, then hydrogen ion reacts with acetate to form acetic acid. We are adding strong acid and formation of weak acid occurs, so the buffer resists changes in pH. Similarly, in the buffer system of acetic acid and sodium acetate, if we add strong base, then hydroxyl ion reacts with acetic acid to form weak base, that is sodium acetate. So we are changing pH largely, but it is changing slightly. So this is what we call buffer. In this video, I will tell you how to solve toughest numericals on buffer part 3. Example. How many grams of sodium acetate must be added to 250 ml of 0.1 molar acetic acid to prepare a buffer with pH is equal to 5, pKa of acetic acid is 4.76. So we have a buffer system of sodium acetate and acetic acid. pH is given 5. What is Ka? Ka is dissociation constant of acetic acid. pKa is the negative logarithm of dissociation constant of acetic acid. So pKa of acetic acid is given, pH is given, acetic acid concentration and volume is given. We have to find grams of sodium acetate. So their solution, there are two formulas of Henderson-Hasselbalch equation. One is pH is equal to pKa plus log salt over acid concentration. Other is pOH is equal to pKb plus log salt over base concentration. Since here pKa and pH is given, we will apply first formula. pH is equal to pKa plus log salt concentration over acid concentration. We will put the values. pH 5 is equal to pKa value 4.76 plus log salt over acid concentrations. When we subtract 4.76 from 5, we get 0.24 is equal to log salt concentration over acid concentration. Because here is a log, so we will take anti-log on both sides. So we will write anti-log 0.24 is equal to log and anti-log cancels each other, equal to salt concentration divided by acid concentration. When we will use calculator to take anti-log of 0.24. It becomes 1.737 is equal to salt concentration divided by acid concentration. Acid concentration already given in the example, zero point 0.1 molar. We will multiply 1.737 with zero point 0.1 molar. We get 0.1737 molar. This is the concentration of salt. Because this is in 1000 ml and we are making buffer of 250 ml. So 1000 ml contains 0.1737 moles. So 250 ml contains, we will multiply 0.1737 with 250 and divide by 1000, we get 0.0434 moles. So we have calculated moles of sodium acetate and weak salt. Now we will calculate molecular weight of sodium acetate. Because moles are calculated, we will calculate molecular weight. Then we will apply the formula of amount. Molecular weight of sodium acetate is 1 is the number of carbon atom into 12 is the atomic weight of carbon plus 3 is the number of hydrogen atom into 1 is the atomic weight of hydrogen plus 1 is the number of carbon atom into 12 is the atomic weight of carbon plus 2 is the number of oxygen atoms into 16 is the atomic weight of oxygen plus 1 is the number of sodium atom into 23 is the atomic weight of sodium. After calculating, molecular weight of sodium acetate is calculated to be 82 gram per mole. We have calculated moles and molecular weight of sodium acetate. Now we will apply amount formula and we will find out amount of sodium acetate. Now we will apply amount formula. Amount is equal to moles into molecular weight. So amount is equal to, we will write moles 0.0434 moles into 82 gram per mole. After solving, amount is calculated to be 3.55 grams. So we will add 3.55 grams sodium acetate to make the buffer of pH 5. In this way, buffer is made. Friends, if you have any question, you can ask me on comments. I can help you. Thanks.